Welcome again. In this lecture, we are going to discuss outlier or anomaly detection, what it is and why we need to get rid of anomalies before training a model. Now, most of the datasets that you saw in the previous lectures that we used for clustering and classification, you might have noticed that there was hardly any outliers. That is, these datasets are pre-processed and are structured for us so that we can directly use them for training different models. There were a couple of datasets that we used for clustering where there were some outliers, and we were investigating the behavior of different clustering techniques and how they are going to deal with outliers. So if the dataset has got outliers, not every technique is going to deal with it handsomely. We only saw that dbScan was the specific technique that was actually excluding outliers from being part of any cluster. Other than that, every technique was accommodating outliers to be part of the cluster, and due to that, the original shape of the cluster was tempered. So what actually outliers are? Outliers can also be called anomalies, and these are the points or the objects or instances or documents that do not comply with the rest of the values. So if we have got a dataset, and in that dataset we have different users and their buying patterns. If there is a user whose buying pattern is very much different from the rest of the data, so that is most probably an outlier. And generally, how outliers can be identified are that there aren't going to be many values around the ones that are outliers. So its values are going to be a lot more different from the rest of the values. If you do not pre-process them, most of the techniques do not know how to deal with anomalies, and they are going to affect the results of whatever the classification or clustering techniques that we are using. Others that may deal with outliers would still have problems with correctly identifying these outliers. Therefore, outlier detection and removal is part of preprocessing. In preprocessing, we try to get rid of most of the problems, if not all, that we have in our data, so that when we provide that data to the model, it should be trained well. So the objective of preprocessing is to rectify all the problems that we have in our data. This may include noise removal, missing values detection, outliers detection and removal, normalization of values to a specific scheme, fixing categorical data, and all other such problems. So outliers, since they are very much different from the rest of the values, it makes their position doubtful to be legitimate. Either someone mistakenly have added those points and the values are not accurate, or the behavior of that person is so unlike the rest of the people that we cannot consider them for predicting the normal behavior of any other user. Now, as we can see with this example, that with the presence of outliers, this is how the model is predicting values for different points. And just because of these few outliers, the model isn't doing well for majority of the values which are legitimate. If we would get rid of them before training a model, now we can see that the predictions are a lot more closer to the actual values, and therefore the model is going to achieve higher accuracy. So that is the effect of having outliers on a model, no matter what the model is. Although there are some models that would be more affected by outliers as compared to others, but in general, every one of them are going to suffer because of it. So if we would just identify these outliers and get rid of them, that is going to be a lot more helpful in improving the accuracy of our mechanism.